All right, so here you can check your work, check your answers from last night's homework. Let me know if there's anything you want to go over, anything you want to review. You can just stop your video at any time, or you can go back and take a screenshot. But these are the problems that were on your homework last night. And we're going to do a little bit more of this today, except the new thing is when I have a number out front. So you didn't need to do that type of problem like this yesterday. Today we're going to talk about it, then we'll talk about reviewing for our upcoming quiz. So here is our work for today. We're going to do the same thing as yesterday, just with that one added step of a number out front. So what do I do if I have a number out front? All right, well, let's check it out. I've got a square root of 8. And what I want to do here is I want to break this 8 down into a product of two numbers. So something times something equals 8. More specifically, I want to figure out which of these perfect squares goes into 8. So I'm always going to start at my biggest numbers. And of course, none of these are going to fit into 8. 16 does not go into 8. Neither does 9, but 4 does. So I can rewrite 8 as 4 times 2. All right, so now that I've got that down, I need to break this down. I need to simplify that. So I'm looking for a number here that is a perfect square that I can take the square root of. So I can take the square root of 4. The square root of 4 we know is just 2. And what's left over? I've got a 2. So square root of 8 is just 2 root 2. And then what I've got to do is take this 7 and bring it down. So 7 times 2 times the square root of 2. And then I can simplify that to 14 square root of 2. So that's all we're doing today. Same thing, just one more step. So let's look at number 2. I'd like you to pause the video here and see which of these perfect squares, goes into 125 evenly. So 125 divided by what gets you a nice whole number. And of course, we'll start down here at 100. That's not going to work. It's 81, no. 64 doesn't work. 49 does not. 36 does not work, but 25 does. So I can break 125. You know, if you think of like $1.25 into quarters, well, 25 cents times 5 gets me $1.25. So our next step here, looking at 25, got to break that down. I can take the square root of 25. So since I can take the square root of 25, I'll break that out. Square root of 25 is 5. And then left over is just my square root of 5. All right, so I've got that down, and then I have this negative 4. So negative 4 times 5 times the square root of 5. So I can simplify negative 4 times 5 is negative 20, and then I've got that square root of 5. And I'll do a couple more problems, and then we'll move on to our review. So a couple more problems here. Which ones do I want to do? Let's do one over here. So 1/3 times the square root of 27. Well, again, I'm going to figure out square root of 27 equals what? So I can't divide 27 by 100. That won't work. 81 doesn't work, 64 does not work, 49, 36, 25 don't work, 16 doesn't work, but 9 does. So I can rewrite this as 9 times 3 instead of 27, because 9 times 3 is 27. So I didn't change the value at all. Okay, now that I've got that down, I've got this 9 here. So I can take the square root of 9, bring that out, and I've got 1/3 times 3 root 3. And my very last step here, well, what is 1/3 times 3? Or what is 3 divided by 3? Well, 3 divided by 3 is just 1, and then I'm left with root 3. And again, pause this video at any time, go back, watch these practice problems, and let me know what I can do to help you out. So let's try number 2 here. -2 times the square root of 147. So I'm going to rewrite the square root of 147 as the square root of, let's see, 147 divided by 144 gets me 1.00 something, so that's not going to work. $147 divided by 121 gets me 1.2. That's not going to work. That's not a whole number. 147 divided by 100. 1.47 doesn't work. That's not going to work. If I divide it by 81, that's not going to work. Trying to divide it by 64. That doesn't work. That's about 2.3, so not a whole number. Let's see, 49. Okay. So 147 divided by 49 gets me 3. So this is 49 times 3. Okay, well now I've got this perfect square, and I can break that on out. So now I've got a -2 times square root of 49 is 7. And then what's left over in the radical is just this 3. So now I've got -2 times 7 root 3. So my final answer would be -14 root 3. So that's all we're doing for today. Again, it's the same thing. The only thing that's changed is we have a last step now where we've got to multiply our final answer, our final simplified radical, by whatever number is in front. So that's the only new step for today. We have a quiz on Monday. It's a quiz on Monday. It's going to have a couple review problems from 1-1. It'll be pretty heavy on our segment addition postulate 1-2. And then 1-3 is our distance formula. That's what we're doing next. That's what we've been preparing for these last couple days. So for right now, I want to review 1-1. And I would like you to pause the video after these questions and see if you can answer them. And then you can unpause it and check your work with my work. So, reviewing 1-1, I want 2 opposite rays. So I want 2 rays that go in opposite directions from the same starting point, in this case, A. So you could have AC and something in the other direction. You could have AC and AE, that would be 1. You could have AB and AD. There'd be another set of opposite rays, again, because they go from AD, because they go from the same center point to completely opposite directions. They form that straight line in opposite directions. And if you're looking at the names here, what's a good color? Green. If you're looking at the names, notice how these arrows at the top all go the same direction. Even though these rays don't go in the same direction at all, the naming convention, remember that the way that we name this is we're going to start at our starting point, in this case A. A is our starting point for all of these. So where am I starting? A, and then where am I going to? In that case, B. So this ray up top tells me I start at A and I go toward B, or I start at A and go toward E, or I start at A, go toward D. So that's why we name these the way that they do, even though the arrows are pointing not necessarily the same direction as they would be on our diagram. It just tells us more clearly what's our starting point, what's our ending point, and it makes things a little less complex. So here, let's talk about planes. I've got this top plane up here. So here's my top plane. And I want to know a couple names for this plane. So again, the things you need to name a plane: 3 non-collinear. This was something that a lot of people missed on our quiz, even though I touched on it pretty much every day, and that's almost always going to happen. You need 3 non-collinear points. This is the big key word, is non-collinear. And what that means, it means not on the same line. So coplanar means on the same plane. Collinear means on the same line. So non-collinear points means 3 points that are not on the same line. That's what we're looking for here. 3 points that are not on the same line. So I could name this plane NMH, or plane KLM, or plane KML, or plane MKL, or plane LKM, or whatever you want to call it. The only thing I cannot name it, and I'm going to put this in a big red circle so that you don't do it. The only thing that I cannot name this, I cannot name this plane KHL, or LKH, or LHK, or HLK. No combination of those 3 letters is going to work, because, again, they are on the same line. They're collinear. So keep that one in mind. And then lastly here, I'm looking at a plane. This is not a point. No dots around it. So I could name this plane V if I really wanted to. That's kind of obscure. So I'm going to color that in black. I'll highlight it in black. It's an obscure way to name it. Not the way that most kids would. But you can name this plane. Actually, I should do it in green if it's good. So this is something I would do as like a last resort. I would name it plane, RST or QST or STR or something like that. You can't use RQS, that would be bad. You cannot use point W because it's not in our blue plane. And then V is not a point and F is not a point. So don't use those. And if I'm looking for the intersection of this line right here and my plane, so line WQ or QW, so intersection of QW and my plane, then I'm going to look for where this line goes from solid to dashed. And where that happens is at point Q. So point Q is going to be where I'm looking at. So my intersection of QW and the plane is point Q. And that's our review. Your homework for tonight is that simplified radical form worksheet, and I would like you to watch the Pythagorean theorem video, just the first like 2.5 minutes. We're not doing Pythagorean theorem, but we're doing distance formula, which is basically Pythagorean theorem. And I wanted you guys to get a quick refresher on that, so it wouldn't be totally foreign tomorrow. So thank you for emailing me, and I will see you tomorrow.